CrewtonRamone'sHouseOfMath.com for more.
All right, so let's talk about control of error. Control of error does not mean you don't let them make errors. Control of error means that you expect error and you control for it. Oh, it's because I'm looking at the wrong one. Okay, there you go. Okay. So control of error means lots of different things. But whatever you're doing is you expect error. It doesn't mean control. Putting a child in a situation where they cannot fail doesn't mean that they're not going to fail. Doesn't mean that okay. So in this case, you could use your tray. That's why we have your tray. But let's just say, well, we're going to build 8s. Oh look, now I've got control of error. What can I build there? I can build 8s here. That's what I can build here. Oh, I made an error. It's not big enough. Oh. But I've got control of it. They can tell they didn't make an 8. Right? Oh, that works. And you will see little kids do this. Well, it worked that time. Maybe it'll work this time too. Oh, it doesn't work. Oh, that doesn't work. I've got control of error. Again, I don't tell them, no, it's not a 2 that goes there. What do I tell them? I tell them, try something else. Oh, that was too small. Or that was too big. Okay, you let them fail their way to success. But control of error doesn't mean you don't let them make errors. Which seems to be, I saw this recently and that was vaguely disturbing to me. That's not what it means. What it means is you control the error. You put them in a situation where they have a difficult time failing, but that doesn't mean that they don't get to try and fail. And they're not afraid of it. And what's the verbiage that you want to use? The verbiage is you didn't get it wrong, you just got more information. Write that down. You're not wrong, you just got more information. What did Edison say? I found 10,000 ways not to make a light bulb. Right? That's good information. And then he found the one way to make a light bulb. And there's questions about whether he found that himself or he stole that or what the deal is. But either way, we came up with the incandescent bulb and it works. But he tried a whole bunch of other stuff that didn't work first. You can try a whole bunch of other stuff. And see, when we talk about control of error also, what you want to do when you're doing control of error is you want to make it visually obvious and you want to put this is less chance for error than this. The reason why because there's only one thing that's going to work there. So what's the success rate on this? The success rate on that is very, very high. That go down. They can see that. The success rate on this is very, very low. Maybe they look at that and they go, oh, oops. Well, that was a pretty big piece, but that didn't work. Oh, geez, that still didn't work. I don't know. What the heck am I going to do here? Oh, okay, that one works. Right? But there's many options. There's a option. Control of error. That's why we have the trays. That's another thing that sets us apart from basic Montessori materials and other people that have knocked us off is that our very trays are used for building 10s and 9s and 8s and 7s and 6s and 5s, and we have control of error just in the trays, those first 25 add-ins. And we've talked about the 25 add-ins and how important those are. Now, when they're building these, 2 hands. You want to use 2 hands. Whole brain activity. Control the error. Get to know out of the lesson. Play. Have fun. Let them fail. Expect the error. Correct the error. More control of error. Now, control of error also with instruction. Your instruction should be, in the case of x squared, 3x and 2, for example, when we were first starting out. What's my instruction? My instruction is, my instruction is build me a rectangle. Now, control of error is already built in. This is not a rectangle. Well, it is. It's 2 rectangles. I want to use all the pieces. Okay, that's nice and creative. Seen kids do this. But I don't have a rectangle, and now all the pieces have to touch. Okay, so you got a rectangle, it's good, but I want all the pieces to be touching each other, no white spaces. Oh, darn it. Oh, got it. I don't care how we got it. Got it. Got it. There it is. That's one way. Like I said, I can tell a lot about a kid that builds it like this, as opposed to a kid that breaks this thing up, puts pieces there, or as opposed to a kid that actually. Don't have a rectangle. Got that piece sticking out. And then still don't have a rectangle. Got that piece sticking out. All right, control the error. The blocks themselves. What was the instruction? The instruction was take x squared, 3x and 2 and turn it into a rectangle. That doesn't mean this is the only way to do it. Or that. And that everything else is wrong. And that right? What that means is we have the ability to tell whether we got it or not, whether the teacher is there or not, because the instruction is make a rectangle. So my rectangle, I built it. So now I can do bigger ones and bigger ones. And once I understand the concept, again, is to use 2 sides and make a space for these guys to fit in. Right? And by the way, this is completing a rectangle, but I'm certainly not completing the square there, am I? If I was completing the square with 3x, I can't use this. I have to take this piece right here, I have to break it up and put it into those 2 over there. Do I have a blue one like that? Why, yes, I do. So I like these pieces. I have these, you don't have these. These are old. But I can take them, take that X and say, boot. And now I can really see that completing the square means take half, and complete the square. This is x plus 1.5 and x plus 1.5. Now I've got a square because both sides are same. That's the definition of a square. And I've seen this. Sonia did this. A couple other parents did this. And I was so oblivious that I didn't even know I didn't even realize. X squared, 5x, and 6. 6 is not completing the square. We're not completing the square with 6. Because that's not a square! Plus 3 and plus 2 does not make this a square. That makes that a square. And that's why I did that whole lesson on squaring numbers that end in 5. So you got to be able to, okay, so now what completes a square? Well, that is 2.5. What's going to fit in here is 6.25. Because 6.25 is 2.5 squared. And we're completing a square, not a rectangle. A square is a type of rectangle, but a square. And this is a very important skill to have later on when we are doing problem solving, especially when we have polynomials that have x squares in them. Being able to complete the square helps us very easily get rid of that square. Because again, no fun, get back to 1. I don't want to know about a square or an x square. I want to know about x. And in order to find out about x, I have to square root. So rather than talk about it, let's look at this.
So do you use Play-Doh to complete the halves missing?
For the little kids, yes. But usually I don't bring this concept in until they're old enough that they can start to conceptualize and draw a picture. Because again, remember, we don't want to do every single problem with blocks, right? We want to understand the concepts and then be able to sketch pictures and use symbols to be able to take the abstraction. If you're working with little kids, yeah, Play-Doh would probably be a good idea. Or they can take the pieces and put them in there. Oh, let's do that. Where's my Play-Doh? I'm just going to use Play-Doh to stick it on there. I'm not going to use Play-Doh to make blocks. But yeah, wouldn't it be fun to have like a little Play-Doh station and have a little... I want to have a little... One day, I swear it's going to happen, where I'm going to have this math kit and I'm going to have worked with Play-Doh and Legos, and we're going to have Play-Dohs and Legos in there, and we're going to have a little thing where I can have like a little factory and I have my Play-Doh or some kind of modeling clay, and you stick it in there and it'll squish out some of these guys, and it'll squish them out in halves, right? And maybe we'll have it'll be slightly bigger scale for little kids, and they can squish out, like it'll extrude a square thing. Remember that I used to have one when I was a kid, and you can push the Play-Doh through and it would make like stars and stuff, and you could cut them up, right? Remember those? Okay, well, we'll push them through and we'll make these guys, and then you cut it off at the 10, and then you squish it through and you cut it off and make another 10, right? And then you can play with the clay and fool around and have your own blocks that way, and they're all squishy, and then you can squish them back up again and put them back in your thing. And telling you, I've got plans. I got plans. But you know what? The big corporations, most of them don't see it. Who's going to play math? Nobody likes math. We're not going to spend time marketing math because nobody will buy our product. And you know what? They're pretty much right. But I'm going to change all that.
Or a 3D printer?
Or a 3D printer. There's a whole other thing. That'll be common. 3D printers are going to be as common. There was a time when if I told you a few years ago, back in the 90s, way back in the 90s, like in 1999, that your 5-year-old kid would have a handheld device in their thing, and that I'd be able to do what I'm doing here on this, right? Look at this. Here's right? Anyway, on my tablet. Oop. Anyway, you wouldn't believe me. And I'm telling you that in a few years, kids will be playing with 3D printers the same way anybody has a printer in their office now. It won't be long. Okay, so I put this guy in here, and I'm going to... let's move down here a little bit. Let's do this. Let's go to the next step. So what we were talking about, control of error. I'm going down the tangent of taking this for problem solving, x squared, 5x, and 6. And I'm going to set that equal to, I want to know what x is. And I could make it at 0, that's easy. But what if I change it to 7? That's not going to work out nicely. Let's make a nice one. Ooh-la, ooh-la. Oh, you know what? Let's just do any number. Let's make that 2. All right. What a pain because of this. If I had 0, it's easy. If I had 0, I don't even have to complete the square. I just factor it. X plus 3, x plus 2. And now I know x plus 3 has got to be minus 3. But I put the right symbols. There's my solution set, minus 2. Because I know I just have to add the opposites. Just have to put the opposites in there, and I've solved it. There's my problem solving. Done! Uh-oh. I'm not going to do that anymore, though. Now I'm going to do, like I said, 2. Well, what number do I have to put in there to make x, what number does x have to be in order for this whole thing to be shrunk down to be 2? Well, that's going to be a pain. So what I'm going to do is I'm going to use my quiver of problem-solving skills. I'm going to complete the square. So here's what I'm going to do. I'm going to get rid of this, and I'm going to do x squared plus 5x, and I'm going to, well, I'm going to use 0, 0 for a moment. I'm going to have -4 over here. How do I have -4? Because what's over here with 2? Anybody? Bueller? Ferris Bueller? Bueller? What's over here with 2?
Would it be 0?
It would be 0. There's nothing over there with 2. Quit being adults. Oh my goodness. Do you see anything over there with 2? No, nothing. We have a name for nothing in mathematics. The name for nothing is a 0. And that 0 is +6 and -6. So I take away the stuff that's same. That's a +6 and a +6. And now I've got 2, -4. Well, why does that help? Well, it doesn't when you get right down to it. But it's gonna in a second, because I'm gonna be able to take that. Now watch, 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 watch. I'm gonna complete the square. What am I gonna complete the square with? What fits in here?
Four and a half.
4.5. 2.5 squared. Remember those lessons we did? Remember those lessons? That's 2.5. That's 2.5. 2.5 squared. And I could do it. You could do that. You could sit there and you could actually count it if you wanted to. 1, 2, 3, 4, a half of 1 and a half of 1, 5, a half of 1 and a half of 1, 6, and then that corner right there, 6 1/4. Also, just so happens that 25 squared is 625, and if I put my decimal point in, I put my decimal point in there, right? Further, I can draw one picture if I like. Remember this? Then I'm going to pick those guys up. We're on top over here and put them over there, and I get another one. If my drawing was to scale. Oh my goodness, let's do that. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Should be half one of these. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Pick those guys up, put them over here, and I get another square. And then I have my little quarter in the corner. 6 1/4. Remember those lessons? If not, go back and look at the other teacher trainings. I know it's in there. I know we did that. I know it. Anyway, so I'm going to complete the square with 6 1/4. So if I add 6 1/4 here, I got to add 6 1/4 there. Let's see, what's 6 1/4? That would be, if I add 6 1/4, that gives me 2.25. Now, if I want to put it into, I'm just solving. If I want to put it into vertex form, I can do that easily. But now I can see that this is x plus 2.5 squared equals 2.25. Doesn't it? Now I got to square root both sides. I'm going to use a different color pen. I should have picked a better problem where I got an even number, but you're adults, so I just concept, because it's going to be the same. So I square root both sides. Now I have x plus 2.5 equals plus or minus the square root of 2.25, because I don't know what the square root of 2.25 is. Oh, wait. Yes, I do. What's the square root of 2.25? Do I know the square root of 2.25? What's 15 squared? Bueller? Ferris Bueller?
It's going to be 1.5.
You're correct. What's 15 squared, though? I asked the question for a reason. 225. Can I just put decimals in? Oh, bro, this stuff's so easy. Even when I try and make them hard, the bugger easy. See that? Oh, no fun get back to 1 by using my square root. So now I have 2 answers. Can I do my algebra? Is there a 0 over here? Or can I write it out? X is the same thing as 1.5 minus 2.5. And x is the same thing as negative 1.5 minus 2.5. Can we do those? What's 1.5 minus 2.5?
That'll be -1, right?
Let's check it and see if I'm correct. -1 squared. What's -1 squared? Okay, good. 1. So what do I have here? I have 1 plus -5 plus 6. Looks like 2 to me. -4 squared is 16 plus -20 plus 6. Let's see, 22 minus 20 is 2. Yep, I have figured it out. Yay! There's my 2 answers. Completing the square helps me get rid of the negative. Control of error allows me to see what's going on here, making my rectangle. So using completing the square just gave me another arrow in my quiver for the other concept of no fun, get back to 1. And of course I had 0 over here. Concept-based teaching. Basic concepts. Starting with a familiar x squared, 5x, and 6 should be fairly familiar to the kid. Shouldn't be scary. Shouldn't have been scary to you. Knowing about square numbers. Oh, I knew about square numbers. Knowing about square numbers and how decimals work, that helped a lot. Squaring that number, squaring numbers that end in 5. More arrows in your quiver. Playing math with this. And what are we doing? Let's go back. Let's deconstruct. Let's go backwards. Let's go back. Well, then I played with numbers that are square. So I played with numbers that are like 1s and 3 and 2 square and a 3 square and a 4 square and a 5 square. And then I got bigger and I built other squares. So now you can see where this lesson will fit into this lesson. Okay, so this is ahead of the lesson that I'm about to show you. And now you see why we do this lesson. Come on, how fun is this? It's easy! It's easy! Let's take 15 squared. Like I said, I'm gonna go back to that lesson because it looked like some of you guys were like wondering what the heck I was doing. All right, 15.
That's not a normal way to solve a problem, you know.
It's not a normal way to solve. It's the total no. What are you trying to say?
I try to say that if you go to school and solve the problem like this, they're going to say, nah, this is wrong. You can't do like this. Wrong. Totally wrong, boy.
Did I get the right answer?
Yeah, before something.
Yeah, but. I know I'm a crazy person. I know it. That one, I don't even have to put anything in there. I'm just illustrating this other point here. Yeah, I'm just dropping blocks like the... I'll just drop that one down there too. And now I'm dropping pens. I don't care. All right. See it? It's a 15 square I just built. Are you building this, or are you just watching? Don't just watch. Build it. Now, I am lucky because I have 2 sets of multi-10s. And as you can see, look at how old this multi-10 is. This block is probably 25 years old. It has the fingerprints of many, many, many children on it. Okay, so now look at this. I'm just going to reshape this thing. Done. Should I make one more trade? I can if I want to. That's why I just go multiply by the next one up. Bro, how easy is this stuff? Can any little kid do this? Yes, any little kid can do this. Any 5-year-old kid can do this. With some help from you. And not too much help. Right? Just direct them. Can you take those pieces and put them over there? Yep. Can I trade the 5 and the 5 for 100? Yep. The 5 10s and 5 more 10s is 100. And you see for little kids what kind of math they're doing? All the little pieces going together. Now, I'm going to draw a picture of it. With your kids, you will play with blocks. And you have more than enough blocks. So you want to get out 4 of these guys. Because now I'm going to do 25 squared. And you'll see this. I have video of this, working with other kids. But I'm just going to draw the picture. I'm going to draw it hopefully big enough that it comes out nicely. So now I want to do... I'm going to use a pen that works. And I'm not going to be in the right colors because I don't feel like jigging around for a red pen. Although I probably have one. Do I have a red pen? Let's see if this one writes. Why, yes I do. All right, so there's that. And there they are. Obviously 25 in the corner, I'm not drawing dots. Pick these babies up. Put them over here. Now that's the same thing as another red one. Woo-hoo. One, two, three, four, five, 6. 25. So now I can start to see, oh, 2 times 3. 2 times 3. That's where the Vedics got it. That's where that rule comes from. So let's see here. I did 15 squared and got 225. I'm not even going to get blocks out. Because it's the same thing. One, two, three, four, 5. 1, 2, 3, 4, 5. Those 5 would have been there and there and there. So there's that one, there's that one, there's that one. Three times 4. I'm playing with blocks.
Okay, I see, but I'm not sure like why you have the 4 and the 3 there. I mean, I see what the block. Yes. It's 2
What?
times.
3 times 4. 2 times 3. 1 times 2. 3 times the 4. Gave me the 12. 2 times the 3 gave me the 6. 1 times the 2 gave me the 2.
Okay.
Okay, that was the weakest okay ever.
Okay, you're saying it's 3 times.
Hold on. Let's see if you got it or not. We'll find out in 2 seconds. What's that one going to be?
4 times 5.
Which is what?
It's going to be 20, 25.
There you go. Why you ask the question if you know? I'm going to get crazy now. Put the decimal in. Put the decimal in. He's a genius! Now I'm just playing with blocks. See, I need a tab and I need a whole lesson on decimals. Shall I do a lesson on decimals fast?
Yes, because my son likes the whole decimal thing. He's been on decimals a lot.
Decimals are easy and fun, as you can see.
Yeah.
Right? Okay, then let's do a lesson on decimals. That'll be a whole other thing. But before we do a lesson on decimals, let's take another short break. And then we're going to quit. $25. $25. There should be a waiting list for these. Nope. Okay. Crewton Ramone's House of Math.com.